Okay, um, doing this video for fire company number two. We're going to deal with the winch that we use on the rescue truck. So this is just going to be a short video um, detailing some of the basic uses and a quick overview of the winch. So that said, um, the training segment here. None of this material is my material. All right. Some of it comes from the manufacturer. A lot of material I've gotten over the years through training. The majority of it is credited to Chief Billy Leach from his big rig rescue training. And unfortunately, Chief Leach passed away a few years ago. But as I put here in my introduction, um, let his legacy of training continue to be with us. So the purpose of the winch in this application is intended for emergency situations where the company may need to stabilize a vehicle or move a vehicle to gain access for rescue. Right. All operations should be conducted within the safety guidelines provided by the winch manufacturer and the fire company policy and procedures. Right. We are not a towing company. We're not a recovery company. Um, the winch equipment is there for emergency purposes. From time to time, I know we've used it to move dumpsters away from trash compactors. Again, as long as we're using the winch within the guidelines of the manufacturer, within the specifications, the weight loads, and things like that are calculated out, there shouldn't be no issues. But this is putting this out there just to spur a little bit of interest and to get some guys out there and maybe do some training. So the winch that we use on the rescue, all right, it's a Warn Xeon 10S winch. The 10 represents the capacity. It's a 10,000 pound capacity winch. The S represents that we're using synthetic rope instead of wire rope. The winch rope is Spidura 3/8 inch, and per the manufacturer has a working load limit of 10,000 pounds. I've been researching this rope, um, seeing if there's a difference between the working load limit and the maximum brake strength. The only thing I can come up with so far is the manufacturer has it as a uh, working load limit of 10,000 pounds, so it matches the winch. the the nice thing about the rope over the wire rope is that it's a lot easier to work with. I found that it's easy to replace if the rope becomes damaged. It's very easy to take the old rope off the drum, swedge the new rope onto the drum versus having to work with wire cable or what we call wire rope. Some of the drawbacks to the synthetic rope is abrasion resistance. So if you're going over an edge, a rough edge, something that could cut or damage a rope, this is going to act the same way. So you need to have some type of padding in place to protect the synthetic rope if it's going to be subject to some type of abrasive damage. Whereas the wire rope is a lot more forgiving in that aspect. So the winch is also portable. It can be connected to hitches that are found around the apparatus. So we have a front bumper mount configuration. We have a rear step mount configuration. And we have a driver side, passenger side configuration. And all these hitches have electric for the winch, which runs off a 12-volt battery. So one of the basic uses of the winch would be a straight line pull. That would be a 1-to-1 mechanical advantage. So as you can see in the picture to the left here, the winch is hooked to the rear bumper hitch, all right, and it's set up for a straight line pull. So here's our anchor, our choker wire here going around the load that we're going to be pulling, anchored back to the rear of the truck. So it's just a straight 1-to-1 pull. So in this configuration, we're looking at about 10,000 pound would be the max limit of the load. In this configuration, we set up for a 2-to-1 mechanical advantage. So again, here's the winch is at the rear bumper. All right, it comes out to a pulley, which we call a snatch block. All right, choker here is attached to the load. So what we're doing is we're actually doubling the capacity of what we can use the winch for. So if the winch is rated at 10,000 pounds, the rope is rated at 10,000 pounds. Basically, we can do 10,000 pounds on this side, 10,000 pounds on this side in a 2-to-1 mechanical advantage configuration, and we can pull up to about 20,000 pounds. And again, if dealing with the either wire rope or synthetic rope, it's a good practice to use the snatch block whenever possible to reduce the amount of rope on the drum. When we talk about winches, all winches need to start out with at least 5 wraps of wire rope or synthetic rope on the drum, and the first layer of rope on the drum gives you the maximum pull strength of the winch. As the layers build up on the drum, you actually start to reduce capacity of the winch. I haven't been able to find anything for the wire rope on this winch. I have been able to find some information regarding winches and wire rope. Some of them say after the first layer of wire rope on a drum, you can actually start to reduce the capacity of the winch by almost 10% per layer. So as you get more and more layers wrapped onto the drum, your winch capacity drops significantly. So you really have to do some calculations on the load that you're going to pull in order to be successful and not get partially through the winching operation and find out that you miscalculated and now you can't move the load because it's too heavy because your winch capacity has dropped down. A lot of times we deal with chain. Just a quick word with chain. All right. According to OSHA, all our chain it should be graded. We'll use chain in rescue service. The chain should have a tag on there that tells us the type of chain, size of the chain, the grade of the chain. So when we do a lift, we're always lifting with grade 8 or 80 chain. All right. So this winch is not a hoist. So we will not be lifting anything with the winch. It's only for pulling on basically a level plane. So rescue work, we deal with paratechs, we deal with anything like that where we're lifting a load, supporting a load. We want to use grade 8 or 80 chain, right? So if we're doing a pull on a level surface, we can use a grade 7 or 70 chain, which if you look at the circle here, this hook is actually listed. It says 7-0 for transport chain. So that's something you're going to be looking for when you deal with chain, right? When we're using a hook, the hook opening should face up. So should the hook fail, it will fail in a downward motion and most likely go into the ground, not cause any damage. So that's just a brief word on chain. So some winch theory. So the greatest force is achieved on the first layer of rope on the drum. As layers of rope on the drum increase, the capacity of the winch line pull decreases. Moving a load with a winch requires understanding certain factors such as surface resistance. So surface resistance, basically friction of the load on the surface, right? There's three factors, and they are rolling resistance on a hard surface. So if you have a load that is on a vehicle that you're trying to pull on a hard surface, um, you can calculate the pull requirement at 5% of the overall weight, right? Uh, Rolling resistance, if it's on a soft surface, if it's on mud, uh, some soft ground like grass, gravel, right? 15% of the overall weight. And I see there's a little spelling error in there. It's grass, not grail. So apologize for that. So 15% of the overall weight if you're on a soft surface. And then we have a damage resistance. So if you're dealing with a vehicle, let's say it's crashed, tires are flat, axles are broken, it's 66% of the overall weight to pull that vehicle. Then we have to deal with gradient resistance. So is it on an incline? Are we pulling it uphill, right? Or are we pulling downhill? Downhill is a little easier because we have the we deduct the weight of the vehicle. So in most cases we're going to be stabilized or pulling a vehicle, say up an embankment. So the gradient resistance needs to be added to the surface resistance. So at 15 degrees, you got to add 25% of the vehicle weight. 30% add 50% of the vehicle weight. 45 degrees add 75% of the vehicle weight. And greater than 45 degrees, you need to add 100% of the vehicle weight to the surface resistance. So in order to get the total resistance, so to understand how much you're going to need to pull, to basically calculate if your winch can actually do the job, you need to take the surface resistance plus or minus the gradient resistance. And this doesn't take into account what they call mire. There's a separate calculation for mire. So if you have a vehicle that is mired in mud, in soft dirt, grass, whatever, if the tires if the tires are stuck in the mud below the axle, you're probably looking at 50% of the weight of the vehicle. If it's up to the axle, I believe it's somewhere around 100% of the vehicle weight. And if it's over top of the wheels, you're looking at 150% of the vehicle weight. So mire is probably something that we're not going to deal with this winch because it's such a lightweight winch. It just doesn't have the power if we're going to be pulling vehicles, out of a mire situation. We did have an issue. We did have a situation once where we used the winch to pull a ladder truck off the front lawn of a apartment complex, and the issue was that the wheels of the ladder truck were spinning because it was just on such a grassy, muddy surface, but it wasn't mired. It just needed the extra pull to get it moving, to get it out of surface. So we were successful on getting the ladder truck unstuck, and not having to wait for a tow truck. But again, you need to understand how your winch works, be able to calculate some of the loads, and just use a little common sense in working with the winch. So I just put together a little problem with the understanding your resistance. So here's the problem. You roll up to a box truck like the one in the picture that has crashed into a small vehicle. The truck has pinned the vehicle up against the Jersey barrier. We need to move the truck to gain access to the patients in the car. The front axle of the truck is broken. So how do we calculate the move using the winch? So first we need to estimate the governed weight of the vehicle. if you can look inside the door, it may give you a governed weight. Guys out there know something about trucks and vehicles, they may have a good idea of, hey, I know this truck weighs about this much. So the truck to the left weighs approximately 14,000 pounds. So if we go to our damage resistance chart, we take the damage resistance, which is 0.66 or 2/3 of the vehicle weight, multiplied by the vehicle weight, which is 14,000 pounds, and we come up with a requirement resistance that we need to overcome of 9,200 pounds. So can we do this with this winch, this 10,000 pound winch? It seems doable. So again, we could do a straight pull, or better yet, set it up with a snatch block for a 2-to-1. So I think that would work the best. So again, you need to get out there and work with the equipment. So just a little disclaimer here. The intent of this segment is meant to spur some interest in training on a piece of equipment that is not often used. However, it is often needed in the most urgent circumstances. So the information provided only scratches the surface of some of the intricacies involved in winching operations. To paraphrase Lieutenant Colonel Grossman from the book The Warrior Mindset, under extreme stress, we never rise to the occasion. We fall to the lowest level of our training. So let's get out there, keep fresh on this equipment. We never know when we might need to use it. So that is all I have. And we'll try to put up some more training videos in the near future. And this is probably should make it up to my YouTube channel, so it'll be out there for to download and look at from time to time. So everybody have a good day.